Hi there, welcome back to Lokad TV. Forecasting product launches can be inherently very difficult to do due to the sheer lack of data and the amount of unknowns that there are out there. However, for companies, it can be very important in order to capitalise on the initial spike in demand that often follows the release of a new product. Today, we're going to be discussing if forecasting new products is actually possible and also understanding how much confidence we can have in these results. So Johannes, unfortunately we haven't got a crystal ball here in Lokad. So can we actually forecast for new products?
The short answer is yes. The longer answer is it's difficult and it requires efforts and the proper math. The bottom line is that when people think forecasting, they think a very specific type of forecast. They think about time series forecasting. So they think like temperature forecasting for the weather. So basically you have a curve that is what you've observed in the past, and you want to stretch this curve into the future. And this is your forecast. And the simplest forecast that you can make is just a moving average. You just say, what are going to be my sales next week? Well, if I just average my sales last week, that gives me like a rough ballpark of where I'm going to be next week. This approach is naive, but it kind of works, except that for new products it completely falls apart. And so that's why people suddenly think of, but then I can't use my moving average technique anymore. And so they think, well, we are stuck, but we are not necessarily completely stuck.
So why does a time series approach not work then? Why does it fall apart?
So again, it's because you don't have anything to average anymore. You want to go back in the past and say, I want to forecast the future by just averaging what I had. But if you want to forecast the sales of a product that you haven't started to sell yet, you don't have any data. So it's and if you just forecast zero because you've sold zero last week, it doesn't make any sense, because if you launch a product, hopefully you will still sell a few units. So the very traditional moving average algorithm just do not work. And it's interesting because most of the early, I would say, demand planning software out there were all relying, I would say, on glorified forms of moving averages. I mean, there are many statistical models that comes with fancy names, but that are nothing but glorified moving averages. Exponential smoothing is a moving average of some kind. Linear regression is barely better than moving average. ARIMA, and then you have like maybe some models like in their naive flavors like Winters or Olds model. I mean, you can add some seasonality coefficient, but the naive flavor are just, again, a glorified moving average where you have like smart tuning on the averaging window, meaning that do you want to average your sales over the last 3 days or the last 3 months?
So how can we actually work out a forecast for something that's completely new? If we take like the example of the iPhone, nothing existed before, like that was similar before that was released. So can we actually forecast for that?
So if you want to make a forecast, or at least I would say a statistical forecast, you need to have a relevant set of observations that are in the past. So you're still trying to project the future by looking in the rearview mirror, but you need to have something to look at. So indeed, if you have a product that is like completely unique, then I would say from a statistical perspective, it's kind of game over. You can't work statistically. What you can do at best is to survey the market and just take opinions on whether people would buy it or not. And obviously this is a very expensive process, so your Apple is maybe going to do it for the iPhone because they had invested, probably even for the iPhone 1, they had probably invested like hundreds of millions of dollars even at the time of research and development in bringing this thing to this market, so you can still afford spending a few hundred of thousands of dollars into doing like smart surveying so that you can have like ballpark estimation of how much you're going to sell. But obviously, if you're launching many new products, you cannot afford to have like such a tedious process. However, the good news is that if you're launching a lot of stuff, then what are the odds that all the stuff that you're launching is something completely new? And I would say in practice, almost zero, because you cannot launch hundreds of products that are like completely new. If you are launching every year hundreds of products, then chances are that they are all variations over the same sort of I would say of theme, of topic, of style or whatever.
So what you're saying there is you can sort of relate an existing product to some sort of feature of a new product.
Exactly. So to have maybe a more specific example, if you're in fashion, then at every single collection you will have new shirts, you will have new shoes, etc. But it's always shirt, always shoes, and so your products have characteristics. So for example, they have sizes, and even if you do not know, you're trying to guess how much units you're going to sell. You know that extreme sizes are not going to sell as much as the predominant size. So that means that actually, if you want to have like a statistical model out of it, you just have to leverage this very insight. So the insight is that you're going to think that if you want to forecast how much future demand there will be for products that I'm about to launch, you need to look at all the previous launches that you've done in the past and to relate the product that is being launched to the old ones through the attributes. And by the way, the attribute approach is probably something that is very, very different from what is typically done in most forecasting software.
So as well as sort of the attributes, now that we're sort of seeing advances in sort of deep learning technology, is there anything that can be used to sort of apply and look at these attributes in a bit more detail?
Yes, I mean, just to get back to maybe the classical perspective on forecasting new products. So classical perspective is first you have moving average models, forecasting model. That's all that you have, literally. So what do you end up doing to forecast a new product? You end up asking the supply chain manager to insert a link between a new product and an old one. So that's, I would say, the traditional approach at forecasting new products. So basically what you're effectively asking is that you're asking a human, a supply chain manager, to tell it the question, tell me which product is most similar to the one that you are about to launch, so that I will be able to pretend that this product has already been selling. And then you can go back to your moving average approach, because suddenly you're back to a situation where the time series exists, you have past sales for the product. But the problem is that if you're launching 1,000 new products and you want to, and you have to take this mapping decision for every new product that you're about to launch, and in your history, you've probably launched tens of thousands of products, then the process is incredibly tedious, because you have to go and investigate an entire, I would say, enormous archive of past launches manually to do those mapping. And if you do the mapping incorrectly, relying only on your intuition, then basically your forecast is completely garbage. Mm-hmm. So a much, I would say, smarter approach is indeed to leverage the attributes, to think of what are the attributes that govern the amount of demand that you can expect. So if we go back to fashion, for example, sizes are a very clear indicator. But color is also a very clear indicator. For example, let's say if you have children clothes, chances are that parents do not want to buy exceedingly white clothes. Why? Because the children are just going to get them dirty all the time. So you don't want to have like impeccable white for children, tend to be not such a great color. But if you're looking for, I would say, business shirts, then probably the dominant color are going to be white, light blue, light pink, and this is it. And if you want to have like bright yellow for business shirts, it's probably going to be like a vanishingly small percentage of your sales. So the thing is that those sort of things we can observe them, I would say, intuitively. And the problem is that the relationship can be very subtle, and the type of attributes that you can have can be very diverse, because you can have size, colors, price points. You can have sort of patterns that are printed on the shirt or on whatever clothes. If you're looking for, if we are not looking at, let's say, fashion, but let's say if we are looking at consumer electronics and you want to forecast the demand for the next printer, then you're going to have like a wide set of characteristics, like the type of cartridge, compatible cartridges, the fact that it has Wi-Fi or not. It's super diverse. And then we are facing a situation where you need to have a statistical algorithm that is able to cope with this, I would say, relatively overwhelming diversity. And that's to get back to your initial question of deep learning. This is where I would say the very modern flavor of machine learning kicks in, is that, let's say, deep learning algorithms are especially good at dealing at incredibly diverse set of features, which can even include, to some extent, like a plain text description of the products if you just have that.
So what you're sort of saying there is there's a huge amount of variability, there's a huge amount of things we need to think about. So can we actually really have confidence in kind of the results of forecasts for new products?
I think that's precisely the point that you try to address with probabilistic forecasts. So first, the amount of uncertainty when you're about to launch a product is typically very high. I mean, again, the market, if it was very easy to forecast a new product, chances are that this product would not be new at all. That would be just like a simple replacement of, I would say, a quasi-substitute that is like a near-perfect substitute for one of the products that you were already selling. And in this specific case, then the matching, the mapping, the manual mapping that I was describing earlier is probably a good fit. But if you're launching something that is at least a tiny bit new, that is not completely aligned with what you were selling before, then there is like some kind of irreducible uncertainty. But it's okay. Again, the question is, it's going to be the same challenge for your competitors. So, future is uncertain for you, future is uncertain for your competitors. If you want to outcompete, the only things that you need to be doing is to just be able at forecasting better than your competitors are doing. Because again, you do not have a crystal ball, but chances are that your competitors do not have a crystal ball either. So if we go back to, okay, we have irreducible uncertainty, then the question becomes, what kind of uncertainty can we expect? And that's where I would say the benefits of probabilistic forecasts kicks in. Because yes, you're going to make a forecast. It's very inaccurate. But the good news is that if you're doing a probabilistic forecast, you are fairly aware that your forecast is inaccurate. And so what you will see in practice is just a probability distribution that is very spread over many possible futures, so that the decision that you take factor into account the risk that you have to have like a demand that is exceedingly above what you forecasted or exceedingly below what you forecasted. I always say, when I say above or below, I mean above or below the average of the probabilistic forecast, because the probabilistic forecast gives you all possibilities.
So if we now talk of things from a Lokad perspective, we're talking about that range of probabilities. The problem with a Lokad perspective is we're looking at things from a whole business perspective. We're looking at a whole catalogue. So if you've got one individual item which has got a range of probabilities, it could be selling a huge amount, could be selling very little, does that not new product, does that not really change kind of the results for all of our forecasts?
Absolutely it does, and that makes the problems terribly more complicated. So indeed, as I've described, so if you want to produce a statistical forecast for new products, you need to look at the launches that you've done in the past, to match, I would say, the attributes to find relevant products, but just like the matching idea, but just completely automated. But then you're correct. If you launch a new product, you're going to displace the demand on your existing products. And the key idea is that to some extent, every product that you launch is going to cannibalize your existing sales, because again, chances are that if you, for example, if you're a fashion retailer, if you start a new type of shirts, well, you were already most probably selling shirts before. So you have a new shirt that comes with a specific pattern that is even more trendy than the other ones. But still, it means that the chances are that you are not going to just gain market share against your competitors. You're probably going to have like your own customers that are going to opt for this product instead of another one that you were already selling. So by the way, so you end up with those cannibalization, which are very, very difficult to deal with. By the way, it's so difficult to deal with that it's one of the main drivers why fashion, for example, has collections. So the idea is that you instead of trying to have like to try to solve this super difficult cannibalization problem, it's actually easier to do a sale, flush out all the previous collections, so that when you restart a new collection, you do not have like subtle cannibalization between the new collection and the old collection, precisely because you've done your sale, and so you've liquidated the stock, so that precisely you don't have like two collections that compete with each other at a specific point of time. But so yes, the answer is, if you want to, I would say, go further with refining your new product forecast, it cannot be done in isolation. If you launch multiple products, they cannibalize what you have, and they cannibalize also, I would say, themselves, because it's probably going to be like a wave of new products that are being launched. The example would be if Apple decide to launch a new iPhone, they will not have the same sales if they decide to launch either one color, it's black for everybody, and that's the iPhone 11, just black, or if they decide that at launch day you can pick from 5 different colors. Maybe having 5 different colors will slightly increase the sales because they have more diversity, but clearly it would mean that there would be also a lot of cannibalization, because people who would have bought the iPhone 11 red would have also bought the black one.
Okay, so you sort of mentioned there sales. That's kind of like adjusting the price of a product to kind of respond to what the market's doing. Is there any way of forecasting that sensitivity of price? Is there any way of seeing if I'm putting a much lower price, this is the likely forecasted demand for a product?
Yes, although that makes the problem even more complicated. And here we are, I would say, leaving the realm of just classical supervised learning to enter the realm of reinforcement learning or more advanced situation. Why? Because fundamentally you control, if you start thinking about the price, you control what you're going to observe. So for example, a brand, let's say, let's go back to a fashion brand. Typically, you've only observed the sales pattern for the price points that you've practiced in the past. So if you decide to move up market toward more expensive price points, that means that you're fundamentally moving toward areas of unknown, where your past data is not going to be very much relevant just because it wasn't in the same area of the same price points. So that's why many brands would do it gradually, by the way, so that they would still have a way to learn and to see. But fundamentally, what happens from a statistical perspective is that the challenge is that if you're able to build, let's say, a forecasting model that takes a price point as input, then you can have a forecast that is adjusted with the price point. So far, so good. The danger lies in what if you start using the output of your forecasting model to tweak the price. So you see, you could say, okay, I'm building a forecasting model where I can tweak the price, and then I am going to do kind of what if scenarios where I am reforecasting the launch of the same product many times for different prices to pick the one price that suits me the most. And here, if you do it, I would say the naive way, you end up with a specific type of overfitting problem. Because you see, if you repeat the exercise many times with many price, chances are that the price you will pick will be just kind of a fluctuation of your forecasting model itself. So you're going to amplify whatever overfitting problem you might have in your learning process. So by the way, overfitting is the problem of having a statistical model that is good on the data that you already have, but not so good on the data that you don't have. The paradox is when you want to make a statistical forecast, you do not want your model to be good on the data that you have. You want the model to be good on the data that you don't have, which, by the way, triggers interesting question on how do you measure that. But we'll probably cover that another day. But back to this pricing question is, yes, ultimately you want to be able to leverage a price, but it becomes exceedingly complicated to do it correctly, especially if you do not want to, I would say, to generate massive overfitting error through exploration of the pricing variable. That's a very tricky aspect.
Okay, so it sounds like that's a fairly tricky sort of problem to solve. So sort of as a final question, what can we sort of see kind of as a near future, and what sort of things can we look at in terms of forecasting new products? What advances are there in technology?
I mean, so Lokad last December we have rolled out our new forecasting engine that is based on deep learning. So that represents, according to our own benchmark, it was probably one of the largest. It was the most significant upgrade that we have ever done in terms of incremental gain in accuracy, and the gain in accuracy for forecasting new products was above 20% of shrinking the error. So it's very significant. Some sort of things that we have earned with this model is also the capacity to really leverage, I would say, the plain text descriptions that can be very useful. For example, if you're a retailer and you want to forecast, let's say, how much unit you're going to sell for Lego boxes, well, chances are, and that's a tricky problem because, for example, Lego is going to have one new medieval castle every year, but this medieval castle should not be confused with the elvish castle. So one is going to be oriented for boys, the other one is going to be oriented for girls. But you know, it's very subtle, and you don't necessarily have all the fine print attributes to reflect that if you're selling like thousands of toys on your store. So again, that's based on the attributes, but you don't necessarily have that much data coming from your supplier, and you don't necessarily have the time to manually add those attributes yourself. So sometimes you want a forecasting engine that is capable of processing like the plain text description. And what we are currently working on is to be able to leverage the history to have more specific, more accurate forecast. As I was saying, for product launches, you need to really embrace the idea of cannibalisation, because you see, the thing is that if you are launching way more products, it doesn't necessarily mean that your sales are going to skyrocket. So fundamentally, all the new products that you're launching competes for the same customers, the customers that you already have. And so one of the research area where we are working on is to leverage the loyalty database, the fact that the sales that you're doing, typically if you're a retailer, you know which client is buying what. So and again, it's completely different from the time series perspective, where you just think of how many units have I been selling, per day or per week for a given product. Here you want to think of exactly the social network of clients that have consumed the products in the past. And intuitively, the idea is that when you're launching a new product, this new product will mostly start by taking shares within your social network, within your existing customer base. So that's a very, very important set of data. And if you want to be able to have mathematical models that are capable enough to process the social network of your clients, you typically have to transition from deep learning to differentiable programming. That is kind of the descendant of deep learning, and that's where we are right now.
Okay, well, we're going to have to leave it there, but forecasting social media and forecasting loyalty are really interesting concepts. So thanks for taking the time for today.
Thank you.
So that's everything for this week. If you're having problems forecasting for new products, we'd love to hear from you. So if you drop us an email or leave us a comment below, we'd love to hear what challenges you're facing. That's everything for this week, but we'll see you again next time. Bye for now.